be placed randomly, but still access can be faster, right? It is not that one way of fast search is that put it in ascending order or descending order, isn't it? So this we have learned it while we're doing arrays and linked list, right? But this is not necessary that every time, because it's a huge database, be placed
The problem
randomly,
of
but still
arranging or
access
keeping
can
the
be
huge
faster,
database
right?
in a
It is not that
sorted
one
order
way of
is that in a
fast
sorted
search
order, the problem
is
is
that
that
the sorting takes a lot of time. The sorting is going to take the overhead on sorting is large. So records may be placed randomly, but still access can be faster. That is the advantage. For example, if you see the graphic, on the left hand side, S1, S2, S3, now they are the keys. And when I give this key to a hash function, it results into some values. It results into values. So S2 is resulting into 2, right? S2 is resulting into 2, S1 is resulting into 0, and S3 after giving to a hash function is resulting into 1, right? So this is what how the dictionaries will work. There are certain keys, and corresponding to certain keys there are the values. Now a word about this hash table. Now our dictionary work by computing a hash code for each key stored in the dictionary using the built-in hash function. As I told you earlier, every key is to be given to a hash function. Now, what is this hash function? It depends on what algorithm which you are using. What algorithm which you are using. The hash code varies widely depending on the key. For example, if you take Python language, as I told you that different languages has got its own way of hashing. In Python, if you are looking for the keyword Python with P capital, the hash value of that corresponds to this huge number. The hash value corresponding to this huge number. But the same Python with this P small, the same Python, though the spellings are same, but here P is cap and here P is small, is going to result into some different number. So let's not get into how this number has come, because this number has come by some function which Python has derived, right? So what I mean to say that the different languages have their own algorithms to give the keyword, that keyword could be string, it could be numbers, it could be anything else, but those keywords are given as a parameter to the function, and the function is going to result into one value. As for the definition of the function, all of you guys know that function is a set of instructions which are going to repeat every time the function is called. A function can take parameter, but if at all the function returns, it returns only one value. So this particular function is going to return the one value, and that's what you are seeing it on the screen. Now let us simplify this hash table further. That there is a key, right? You have a key which you are giving to a hash function, right? A blank box. We do not know what is the algorithm for this, so let's call it as a black box. So this function is based on the logic in this black box, right? So this hash function is going to come out with some value. Will come out with some value. So simply saying, define a function h, define a function h, so that h of key, what is key? Key is this parameter, which when given to a hash function is going to result into I, right? Where I is the index and h is for the hash function. So this key is given to a function which is going to result into a value, right? So this is a simplest kind of explanation which we can give. There are two kinds of hashing, static hashing and your dynamic hashing. So we are focusing on the static hashing. For example, as somebody was telling me that what are the keys? The keys could be a string. Just now, I have taken the example of Python with P capital and Python with P small, which result into number, right? Suppose John Smith, I'm going giving to a hashing function. What is this hashing function? What is the logic for this hashing function? Which let's not be bothered about that. It is only consider that it is kind of a black box, and that black box works on some particular fixed algorithm, right? So when I give John Smith, it's going to result into 1. When I input Lisa Smith, it's going to result into 0. When I say Sam Doe, it's going to result into 3. And when I say Sandra D, it's going to result into 2, right? Now, I'm sure some of you must be getting in doubt. So suppose I take out some name. For example, suppose I say Rohan, right? So will it, suppose M Rohan results into 1, what happens, right? That's a possibility. It cannot be that John every say string will have a absolutely unique kind of a thing. So it's quite possible that suppose I give M Rohan in place of John Smith, it may result into 1, right? Based on the algorithm, you cannot rule out that possibility. And this is exactly what we say collision, right? So say John Smith has resulted into 1 and M Rohan also has resulted into 1. So the collision has occurred. So does it mean that this John Smith will be replaced with M Rohan? No. There is a separate way of handling it. Therefore, as I told you, the second part of this particular unit 2 is going to handle when the collision like this occurs. So uh, the possibility of collision cannot be ruled out. And if the collision happens, what we should do, we'll study this in the second part of unit 2. So let's focus only on the dictionary part. Are you guys able to hear me, and are you able to understand dictionary? Dictionary is a set of key, and this set of key, every set key has got a corresponding value. Now, how to reach to this corresponding value is depending on the hash function. So the key is given as a parameter to a hash function, and this particular parameter, when the function is executed, it results into a single value, right? It results into a single value, and that is how the hash tables are done. So these are the, this column has got keys, this column has got hashes, right? The values, the keys and values, when you put it in a tabular form, it is your hash table. Two keys cannot be same. Goes. Two keys cannot be same, but it can hash. It can hash into a common value. For example, that's what I was giving that example. Suppose John Smith hashes to 1. So also M Rohan hashes to 1. That possibility is there. And that possibility is what we call as collision, right? That possibility, what we have called collision. Does it mean that M Rohan is equal to John Smith? No, absolutely not, right? So when such kind of collision happens, then there is a technique of handling this collision in a different manner. Goes, Sarah goes, right? So this is how. Let's go further. Now there are now the let me deal with an example of this hash function, right? Because it cannot be that, sir, it is not a library function that you call a hash function and use it. No, you have to devise it, or you have to use one of these techniques. One of the techniques is division, right? The second is mid square. The third is folding, and the fourth is, say, digital analysis. So these are the techniques of using the hash function, right? So, for example, the hash key, the key 1, 2, 3, 4, 5. When I take the modulus, right, divide 1, 2, 3, 4, 5 with 6. The modulus of that results into 3, right? Then I say 67564. Mod of that results into 4. So what am I doing? I'm giving this key as an input to the function. This particular function, what it does, it takes the parameter, takes the modulus of that, and when the modulus is taken, is going to result into an integer value, right? So this is how we are going to work on it. Okay, so this is one example. The again 34237 mod 6 is going to result into 1. So as Gauss was asking, that these keys can hash into common values. Now, I have in this particular table not taken an example, but you cannot rule out the possibility that it will not result into same 3 or same 4 or same 1 or 5 or 2. When it happens, what we should do is is the second part of this unit 1, right? So I was talking to you about the hash function, and that's why one of the ways of this hash function is that we write an algorithm which will take the parameter, take the modulus of by 6. 6 is some number. It could be 7, it could be 11, depends on what you choose, right? And which results into one value. Okay, so this is how it happens. Now come to skip list, which is a linear list. You already learned linked list is a linear list. The second part of unit 1, if some of you have focused on the unit topics in this unit 2, the second particular topic is the skip list. So let's understand the skip list, right? Let's understand the skip list. I put the diagram in front of you. And based on this diagram, I'll first explain what is a skip list, and then we'll try to do the coding. We'll try to do the coding which will satisfy every requirement of this skip list, Okay, but first and foremost, let us first understand, like how we understood dictionary, we should also understand skip list, right? Now, can we make the search faster for sorted linked list? Right, is the question. As I told you, as you are seeing it, this is a linked list, the bottom part of it, and 10, 20, 22, blah, 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 everything is sorted, right? So for searching, one of the technique what we understood, one of the technique what we have learned so far is that sort it so that it can be, you can easily go to a particular value because everything is sorted, right? If it is kept it in a random order, then it becomes difficult. You have to go to from node to node to node to node and then find out. If it is sorted, you know that it is going to be in a sequence. Okay, so the question is, can we make search faster for a sorted linked list, right? So what we do, we make the use of this skip list technique. Now, on top of this lower sorted linked list, you can also see one upper, what I'm calling as express lane, and this is called as normal lane, right? Express lane and the normal lane. For example, in Hyderabad, we have this metro and we have the MMTS, right? So if you want to go faster, then it is better to take your metro, because you know that every 5 minutes there is a one train which is going to come on the route, whereas the MMTS, the frequency is not that good, right? So for example, the metro is an express lane, whereas your MMTS is a normal lane, right? So something like that. Therefore, I called it as express lane. So when we have this sorted linked list, both are sorted as you can see. This is sorted in the ascending order, and the express lane is also sorted in the ascending order. Now, what is this skip list? Now, when we come to the skip list, the idea is simple. We create multiple layers so that we can skip some nodes. I don't think understood absolutely clearly. Now, let me take one example. Suppose somebody asks me is number 43 there in the linked list. Is number 43 there in the linked list. Now, firstly, we said that once you sort the linked list in the ascending or descending order, the search operation becomes easy because you are coming incrementing and testing and reaching, yeah, 43. But reaching 43, what we have done, 1, 2, 3, 4, 5, 6, 7 operations we have done, right? 7 times we are tested, we have put it in the loop 7 times, and then we have come to 43, right? What the other way? The other way is that have an express, right? First, I come to 10, right? Is it 43? No. Then I ask the next node for the value, right? It has come 30, right? It is not 43. Then I go to next. It is 57. Since it is crossing 43, what I do, I come down from here, right? With that, straight away, what I have done, instead of going 1, 2, 3, 4, 5, 6, I have just tested 3. So straight away, I have reduced the number of searches from 6 to 3. From 6 to 3. Are you getting my point? I have to go up to 57 because I cannot come down here and start searching for 43. If that is so, then I can come down here also. Then there is what is the advantage of this list versus this list? Right? There is no express advantage of this express lane. Therefore, first I go to the express lane. First I go to the express lane. I look for 43 here, not found. I look for 43 here. 43 is greater than 30. So I look for the next, right? Because I do not know it is in this particular bracket or it is in this particular bracket. So I need to come here and need to go there. Once it is more than that, I come back to the previous node and then step down and find. So 1, 2, 3, and fourth job, I got my number. That's how the skip list is definitely faster than your sorted linked list. Are you getting my point? So same thing. There are 16 nodes and 2 layers. 16 nodes and 2 layers. These are 1 to 16, and there is one layer called as normal lane, and the second layer is called as express lane. Or any doubt so far as far as skip list is concerned? Those who have doubt, please ask me. Only those who have doubt. If you understood, please do not clutter the chat box is clear. Understood. I'm I'm particularly focusing on those guys who have probably not understood the skip list. And one more thing I want to say, it can be multiple error. In this diagram, the normal lane, the express lane, this express lane can have multiple layers, right? This is the first layer, the second layer, the third layer, and the fourth layer. It can go depending on your algorithm. It is not that always there's a normal lane and there is only one express lane on top of it. Okay. Something Sri Ram or somebody is having a query. Oh, okay. If you are understood, I'm fine with it. But fine. So let me go further. Now, as I already told you, the upper layer, that is this one, is called as express lane, which connects only the main outer stations, right? So if I want to continue with the example of metros, when the study for the metro stations was carried out, they first identified that which are the places where the people first get down to go to that particular area. For example, let us take our KMIT. Okay, so Narayangoda, you get on at Narayangoda and then you spread further, right? The surrounding areas. So what they do is that the express lane is Narayangoda, and as it was initially told, it is unfortunately has not picked up in Hyderabad, but they said that there are what they call e-cycles. I think I'm right. in taking that terminology. It has not picked up actually, but in other countries, like particularly in USA, I have seen that those e-cycles are very, very frequently used. The moment you get down from the station, you come down and there are e-cycles. You swipe your card, the bicycle unlocks, and take that bicycle and you go to the nearest spot. For example, you get down at Narayanguda, you take a e-cycle and come to a KMIT, right? Or you get down at Narayanguda, you take the e-cycle and go to Shanti Theatre. Yeah. So that is how we do that. You can't say that why can't the metro go to game 19 directly, right? It is not possible. So we get down from 30 and go to 43. Okay. So the upper layer works as an express lane which connects only the main outer stations, right? Then the lower layer works as a normal lane which connects every station, right? So the lower layer, that is the normal lane, will have all the nodes, whereas the express lane will have only the important nodes. Okay, so let's take one example. We want to go to 50. We want to go to 50. So what we do? We start with 10 in the express lane. 50 is greater than 10. So move next. Next node is 30. 50 is greater than 30. So move next. Next is 57. So what we go? We go back and come down. And this 30 is not same. So move to 43. No. Move to 45. No. Move to 50. Yes, we found it. Now suppose I ask for 51. Say, so the fast lane technique is same. We come to 10, we come to 30, we go to 57. 51 is greater than 57. So I come down from 30, go to 45, go to 50, and after 50, if I find 54, I simply spell out that 51 not found. 51 not found, right? So either the number which you are searching is found or it is not found, but the search operation is faster. The search operation is definitely faster. So that is what we have to understand over here. Let's go further. Yeah, keeping the same example. This I have already explained. So let me now let us try to convert this particular logic into our code, right? As far as we understood the technique, right? The simple algorithm is understood. Okay, but now we need to convert this into your C. Okay, so on the net we have ready-made code, but I'm not trying to find stick to that particular ready-made code. Putting the diagram in the mind, let's try to write our own code, right? And try to make it as efficient as the skip list demands. Okay, so what we need to do is that we have taken hash include stdio.h and stdlib.h. Now hash define min minus 9999, hash define max 9999. Okay. Now what is this business of hash define 9999 minus and plus? I'll explain to you. Then I have taken some variables, that is global variables, that is the level and the count, right? The level, as I told you, that the layers of this express are not restricted. It could be in the diagram it was shown 1, but it is quite possible that you might have the second layer or the third layer or the sixth layer or the seventh layer also, right? So for that purpose, I have created one level which is going to keep a tag of at which level you are, at which level you are. Then similarly, the other global variables which I'm trying to consider are the flag and pound key, right? Presently, you may not get how it is going to be used. Once we start writing the code, I'll link it up. So used in search and insert between function, using search and insert between function. So that's the reason why I have created a flag and a pound key found. Now, express node. So before I show you an express node, now they are the linked list. They are the linked list as you are seeing it over here. Now, if you have to have this, can you write a linked list which is going to represent the express node? Now, what is the express node? This is the express node, right? All of you pick up a paper and looking at the explanation of the script list and looking at the explanation I have given in the diagram, can you create a structure? A structure. Now, all this is a single linked list, right? This is a single linked list what we are going to do work on. So the first and the foremost is that create a express node structure. All of you, please pick up your pen, write it, and any one of you who has done can put it in the chat box. I'm talking about this express node. That is the top one, right? This express node, I have to create a structure like the linked list structure. You said struct node, then curly bracket, int data, struct node pointer. What you must be remembering when we are talking of express node. Are you guys trying out? Don't be afraid. It may be right, may be wrong. Doesn't matter. Please come and put your structure in the chat window. Surya Teja, can I have your structure? Okay, Durga Prakash. What do you visualize? You have to create a structure. Just write down your structure and put it in the chat box so that we can discuss on that. Surya Teja. Anybody? I'm just taking some random names. Or all of you can also put it. Yeah, try it out. Surya Teja. Okay, try it out. I want you to write the structure of this express node. Struct, give the name of the express node as say express node itself. Don't give some funny names like Zombo, Rombo, Bhima, all those things. XYZ, no. Let's name that as express node itself so that it makes sense. It makes sense. Can we have two different structures, one for express node and other for normal node? Yes, I agree with you, Nikhil. Therefore, I'm asking only express node. We must have two separate linked lists, one for express node and one for normal node. You're right, Nikhil. Yeah, but the problem with the array, Durga Prakash, is that array, we are talking about huge database, right? So how can you imagine that this array is of going to be of what size? Therefore, we are not reducing it to arrays, but we are going a little further. Okay, Rishita has given something. Struct express node, very good. Int data, struct express node lower level, uh, lower level node, and next. Good. Well tried, Rishita. Can somebody improve on that? Durga Prakash, struct node. Okay. Acha, you are considering array of pointers. Array of structure pointers. Okay. That's one way. Uh, yeah. Anybody else? Surya Teja, are you done? Aman Jolly, M. Rohan, right. Take a minute. Have your own data structure, all of you. Do not look into the chat box and take the hint from somebody else. See, look at this 10 as Rishita. Let me discuss what Rishita has done it. In data struct express node, pointer next and skip. What is skip? Okay, coming to this Rishita's point. She has got int data. What is this int data, Rishita? Can all of you please wait for some time till I finish with Rishita? Do not populate the chat window. The chat window is small. I'm discussing with Rishita. Rishita, int data. What do you want to store in this data? Only let Rishita work in the chat window because her structure will go out of the chat box if all of you populate the chat box. All of you, do not type anything. I'm talking to Rishita. Rishita, what do you want in this int data? Rishita, can you hear me? Yeah, said struct express node. I like the name express underscore node. I like your name, a very relevant name. And int data. Rishita, my question to you is that this data, what are you planning to store? Hello, Rishita, are you there? Balakundi, Rishita, are you there? Data contains. Acha, you are written. Oh, okay, fine. Okay, I had taken it up, so I was not knowing that you are responding. Sorry. Uh, 10. Data which struct node contains. No, Rishita. Let me give a hint. Let us not deviate from the key and the value concept, right? We are implementing dictionary through struct node, Rishita, right? So the data is not something random. The data is your structure should be able to store your structure should be able to store something like a key and something like value. Other things, I appreciate that you have made a provision of a link to the normal link lane and a link to the next. That well done, right? But this data, instead of data, what you have to store for a particular key, you are going to get some values. For a particular key, you have to map some values, isn't it? So that particular concept should be there in your structure. Anybody else who has done on this particular parameter what I have slightly given you a hint? Has anybody worked on key and value concept? Uh, Akshita. Akshita has said express node, int key, int value. Int key, int value, fine, Akshita. But see, if you see the diagram, 10. 10 has got a single linked list which comes to, suppose you are in the express node and 10, right? Express node 10 key should result into value say 10, right? But from this express node 10, how will you come to the normal linked list 10? It has to be a pointer. As Rishita had made some provision, pointer to the lower level. Somebody has done it. Akshita, yeah. So key value express node forward. Okay. Forward is where? Forward in the same express node. Now there are two things which are required, right? One, you have to have a link to the normal lane, and one you have to have a link to the next node in the express lane. So Akshita, your forward is going in the express lane, or has it stepped down to the normal lane? Yeah, but do you need a pointer coming to the normal lane also? You have to make that provision also. Am I right? Because see, what is the express lane? I'm looking for say 23. So I go to the next, I come to 30. 23 is greater than 30. I come back here, come down, and then go in the normal lane. So that mechanism, that provision in your structure should be made so that I can come down in the normal lane and then normal linked list go next, next, next. Right. Anybody else who has worked on the key value? Something like Akshita has said something like say forward and link to the normal lane. If somebody has worked on that, okay, struct node curl, struct express node. How will you store Jolly? How will you store the value? What about the key and the values? What is your cur doing? Node and struct express. So this struct node cur is coming down and struct express pointer next is going to in the express node. Yeah. Express lane is your struct express next and coming down is your cur. Am I right? Right. Okay. But how about the key and the value? That also you have to store in the structure, isn't it? So you should have the facility like Rishita had taken something as data. So we can replace that data with key. And also some value. So slight modification is required. Okay, great. So all of you are generally thinking right since it has come to the implementation of what we have learned. Right. So what I'm doing is type def struct express node, right? You understand this type def? Uh, yes, Aman, but you have to make a provision to save it. No, that key has to be there. Has to be some element in the structure where I can store key. You have to make the provision, isn't it? So hash define. So type def struct. What you can do, type def struct means what? Again, every time, like how Aman has written express node pointer, instead of saying that, I'm creating a variable which is of express node type. So next time I want to create a variable of express node, I need not have to write struct express node and some variable name like cur. Okay, I can just write express node. So that is what the meaning of this hash define. Hash define is clear, students. Is there a problem with the hash define? Are you understanding what is hash define? By using hash define, what we can do, because it's going to be a very long program. It could be minimum 200 lines of program, right? Or more than that maybe, to incorporate insert, delete, search, display, all that provisions. We have to write different functions, and those different functions, when you start coding it, probably it may run into 200 or 250 lines of code. So to reduce the statements, we do type def, so that I I reduce the coding. Okay, so type def, I'm keeping it in the what global area, so that all the functions can access this express node. Right. So one way of doing that is I'm putting a level, because as I told you, it could be level 1, level 2, level 3. So I'm just keeping a tag of the level, so that int level. Then I'm storing a key. That key could be 10, and corresponding to 10, I may be having some value. So I have placed the value over there. Then struct express node, this express next. So 10, I should be able to go to 30 in the express node, because this is a node of the same type. So I'm creating a pointer, self-referential structure. I'm creating a pointer. So struct express node, express next. Right? In the express lane, I'm going to go to the next. So therefore, I said express next. Then struct express node down. Now, probably you may not understand what is this down business. Now, this down, there are two downs. Okay, one is coming down to the normal lane, and other is, right, as you are seeing it in the diagram. This is the, say, layer 1. Now let us focus on the second diagram. Layer 1, layer 2, layer 3. Okay, so this is also is express node type. This is also express node type. This is also express node type. So from one express node, I have to come down to the second express node, to the third express node, and then to the normal. So the second express node, which I have said down, is coming from one express node to the second express node. Therefore, it is express node pointer down. And the third one, this is what is your struct node. Struct node, right? One of the students asked me, sir, can we split this into two? One is the express node, and the second is the normal node, right? So this is coming down. So go to the node from level 1. This is, if I take this as level 1, from level 1, when I want to come to the normal lane, then I'm using this particular pointer. When from one level to other level, but continue to remain in the express node, I'm using this down. Horizontally, when I want to go to 14 to 34, I'm using this particular pointer. Students, those who are having a doubt, please come in the chat window. Is this structure understood? Is this structure understood? Those who are having a doubt regarding the structure, please come in the chat window. What are those multiple 14 layers? Right. Okay. Yeah. Thanks. Multiple 14 layer. Rohan. Rohan Venkatpati. See, in this diagram, there was a normal lane, and on top of that, there was one express lane, right? But I said that this express lane could be in multiple layers, in multiple layers. Okay, as you are seeing over here, from 14 in the at the level one, from 14, the next node is 34, right? The above could be from 14, it may be going to 55. From 14 it may be going to 55. So when I'm going, when I'm coming from the top, when I'm coming from the top and I'm looking for 23, I'm looking for 23. So what I do is I go to 14 and assume that next node here is 100, right? So I will come down. Assume that the next layer here is 75, right? So 23 is higher than this. So what I do, I come down, right? From here, the next is 34. So from here, I come down to your normal lane. This 14 business is understood, Rohan? Right. See, the layers are put to do the search operation faster. The layers are put to do the search. For example, suppose I am looking for 101. Suppose I'm looking for 101. I put a lot of layers. From here, the next node is at 100, right? So when it is at 100, I straight away come down to 100 and go to 101, right? If I follow this, I go from here to here, I go from here to here, I go from here to here and come down and come back and then come down, right? So instead of so many iterations, what I do, from 14, I go to 100. From 100, I come down to the normal lane, and what I do, I go to 101. So that is how I'm trying to reduce. I'm by putting more layers, I'm trying to search faster. Anybody who has still not understood the multiple layers? Okay, great. So what we have to make a provision that this what the first one express node is going horizontally in the same level, right? This down, this down, we are still in the express lane only. We are still in the express lane, but the next lower level. And this any NXT, we are coming to node, right? We are not a defined node, right? So it's a structure within a structure. It's a structure within a structure. This particular pointer is a stuck node, whereas this particular pointer is stuck express node. Clear? It may look a little complex, students, but very interesting. If you do the coding yourself, you'll find it very interesting. It is such a nice kind of an exercise to your logic that once you do it, you will really enjoy it. Okay, so what I'm doing is, as somebody, I think Aman saying something like cur. So cur is current or a temporary one. So what I've done, I've created some pointers which will be useful in insertions, sorting, searching, deleting operations, right? So what I've done here is express node. I've declared some pointers which are again in the global area, which are again in the global. These variables are in the global area. Uh, like when we were doing linked list in the unit one, right? Temp1, Temp2, Cur, all those first, last, this also they will be useful. Therefore, we are in the global area. We have created a struct def. Now, if you notice over here, this express node and this is also express node, but there E is small and this E is capital. Okay, so express node and a pointer express cur and a pointer express first, pointer express last, pointer express temp1 and pointer express temp2, right? Otherwise, what I have to do? Express struct express node this. I have to write this much. So because of the type def, I have reduced a little bit of code. I have reduced a little bit of code. So all this particular thing, this code is in the global area. The complete code is in your global area. Students, are you with me? Somebody who is not understanding the variables. Once I start writing the code and start utilizing these variables, you will connect. You will connect it. Right. Now, let me go to the next structure. Let me go to the next structure. This structure, I'm talking about this linked list. So this linked list need not go down. It has to only go horizontally. It has to go only horizontally, right? So I have the key, I have the value, and struct node next. And the name of this struct node is node itself. Are you clear? Now again, because I'm doing type def and this node, so I'm creating multiple variables, multiple pointer variables of the node type, multiple pointer variables of the node type. For another previous cur, first, last, start, temp1 and temp2. So this cur temp1, temp2 as a temporary one, the last is meant for the last node, so storing the value of the last node, and the first is meant for storing the base address of the first node. Clear so far? Anybody is having doubt about the node or the express node structure? Only that person need come in the chat window. Only that person need come in the chat window. Right. So Rohan Venkatpati, it is like this. When you want to insert, right, you cannot suppose somebody says, I would like to insert 21. I would like to insert 21. Now the 21 has to be pushed between 20 and 22, right? If I have to push it between 20 and 22, I must first in temp1 save the address of the next, which is 22 presently, right? So what I do, I come over here, store the next address in temp1, create an isolated node, To this isolated node, the next of this isolated node should get connected to 22. And the next of this 20 should get connected to this newly created node. That's the reason why you sometimes require temp1 and temp2. For example, when you are in the express node, you have to come here. Suppose I'm looking for 27, right? 27 is greater than 10. So I come in the express node to 30, but 27 is less than 30. I come back. How do I come back? How do I come back? So in temp1, I'll store the address of 30. In temp2, I'll advance it to 30. So temp2 of value is higher than the search value, right? So from the temp1, I come down and start proceeding like this. Rohan Venkatpati. Okay, so that's the reason why these are the temp1s and temp2, right? Okay, now let us start thinking of to sorted linked list. 2 layers. Let's not complicate life by 6 layers or 10 layers. Right? Let's first try to understand 2 layers. Now, if you see the diagram, I'm sure that diagram is in back of your mind, is at the back of your mind. Two sorted list. There are only 2 layers. The lower level, that is called a normal line, and the express lane. Normal lane and the express lane. These are the two sorted linked lists. Right? You must have noticed that both the linked lists are sorted. Both the linked lists are sorted. Right? So each element can appear in one or both list. You agree with me? Each element can appear in one or both. For example, those keys which are there in the express node, that is 10, is also there in the normal node, which is 10, right? So the key can appear in the normal lane, or it can appear in the express lane also. Yeah, provision you have to make, right? From 10, you should be able to go to 34 in the express lane, right? So one algorithm means when you are writing the code, this algorithm should be at the back of your mind. Quick, in the express lane, jump from one express stop to the next express stop, right? Second, from any express